Hey scholars, so we are getting ready to wrap up our statistical unit. So once again, by this point, we're not necessarily learning about new content as much as we are taking old content and now applying it into the world of statistics. So we're going to use the results from redistributing data from an experiment into groups to determine whether the original difference in means is significant. So I can understand that the difference in means can be modeled by a distribution that is approximately normal in shape. I'll know I've got it when I can justify whether there is evidence for a statistical claim by using proportions in the normal distribution. Right. So first and foremost here, you should notice there is some type of similarity in the behavior of these distributions. So with your peers, let's start some discourse. What do you notice? What do you wonder? Before delving into a little theoretical experiment. So to see what might be happening when we regroup data, consider an experiment that takes 12 subjects and divides them into two groups at random. They tell you what those groups are. Find the difference in means for the original groups by subtracting the control group mean from the treatment group mean. Obviously, there are no means located here, so you'll have to use the Desmos functions that I had taught you 2 videos ago with the data that's been listed here. So make sure you go over to desmos.com and create your 2 lists. So when we have a smaller data set like this, we can actually consider the different arrangements of the data. There are 924 distinct ways to separate the 12 values into 2 groups of 6. And our frequency table here shows all the possible differences in means and how often they occur. Notice that a difference in means of 4.33 occurs 7 times, and the difference of negative 4.33 also occurs 7 times. The dot plot takes this data in the table and represents it graphically. What proportion of possible groupings have a difference at least as great as the difference in means for the original groups? Okay, so that goes back to this first value here. You must calculate this in order to be able to answer number 2, and then obviously using the frequency values over here to validate and supplement your answer. After you supply a response here, I need one up top too. We'll head on over to this slide where the proportion you calculate represents the probability that the original difference in means could be due to the groupings themselves. Based on the proportion you calculated for this situation, which description is most accurate? Since the proportion is so low, it is unlikely that the difference in means is due to the randomized groupings, or the proportion is not low, but there's still some type of likelihood. So theoretical questions, theoretical answers. Be sure that you supply some thinking or evidence to justify your answers for both scenarios. Oops. All right, so is it feasible for us as statisticians to be able to regroup the data ourselves? No, we'll be here forever, especially as like the last one had 924 different ways with 12 numbers. Most studies have way more than 12 data values. So we'll have to run some simulations. So I'm going to spare you me reading it all. So you can pause the video and read it yourself. But what features of the distribution in the histogram here let you know that modeling with a normal distribution is reasonable. If you are not sure of what a normal distribution is, I would head back to anywhere between lessons 8 and 12 for a quick refresher. So using that simulation, model the simulations using a normal distribution with a mean of 0.0021 and a standard deviation of 0.112. What is the area under this normal curve that is more extreme than 0.27? So like I said, at this point, we're not learning new content as much as we are applying old content to this situation. How can that area be used to compare the difference of means from the simulations to the difference of means for the original groups? And based on the area under the curve, is there evidence that the original difference in means is likely due to where the bird spent the 5 years, or are there some other extenuating circumstance that we are not considering? Okay. That will do it for this activity. And as always, I strongly encourage you to read the lesson summary because they do a phenomenal job of breaking down the content to a lesser degree. And we'll pick it up together in class.